Okay, this video is over ordering numbers, and just so happens that these are being ordered least to greatest. So in order to put these numbers from least to greatest, I kind of need to know what they look like. I can't just automatically see these and say, oh, that one goes first, that one goes second. It's too hard for my brain to figure it out. So I like to have a calculator handy to help me figure out the decimal value of all of these. Once these are in decimal value, it's much easier to see what's happening. So let's take 37 and divide it by 6, because that is a fraction bar. That is actually what fraction bars mean. They mean you can divide. So I'm going to take 37, divide 6, and get the decimal for it. It is 6.16 repeating. So I'm going to write 6.16 repeating like that. This next one I don't really need to put in my calculator, but I do know that I do need to know that this bar over the 17 stands for a repeating decimal. That means my number looks like this: 5.7 or 5.17171717171717 forever and ever and ever. It just keeps going on and on and on. Okay, just like this one did. Kept having sixes forever and ever and ever. I just didn't write it. This one was the square root of 33. Square root of 33 is 5.74456. So I can also round this one, 5.74. That's enough. The next one, negative 26 over 5. So 26 divided by 5 as a decimal is 5.2. But it was a negative 5.2. That's important. All right, so since we're ordering these from least to greatest, which is smallest to biggest, we are looking for the smallest numbers first. Now, the nice and easy thing about this is these negative numbers right here are definitely smaller than these positive numbers. So we have to put those first. Now remember, excuse me, now remember that the bigger the negative number actually looks, the smaller its value actually is. So we always check with the first decimal place. We see which one is in the first decimal place, because technically this number looks way bigger than just plain 2, but it is not. This has a 1 in the first value, and this one has a 2. So the 2 would have made this number the larger number if it wasn't negative. But it is negative, which means that this technically is the smallest value we have, and then it's this one. So I'm going to put it in order of this one goes first. So negative 26 over 5. This one goes second. So negative 5.17 repeating. And then I go and look at these two. This one is a little bit easier, but I definitely wouldn't have figured this out if I was just staring at the actual numbers. 5.7 is smaller than 6.16 repeating. Oh, I'm gonna write the actual value that it gave me. And then 37 over 6. And that is the answer to this question. You will have questions like this. All right, ignore this table down here. That's for the next question. Here's another example. It says lists. We're trying to put this list from least to greatest. I did not have the other answer choices. I just took this answer choice, and I'm going to see if it was in order or if we need to order it. So least to greatest. The only number that I can see out of this list is actually this 0.7 here. All the other ones are kind of in disguise. So 65%. It is always a 2 decimal place move. You can, sometimes some calculators will have percent signs. So this one has a percent sign way down here. I can type 65 and get a percent button and get a decimal for it. Or it is just as easy to know that anytime you have a percent, the decimal place moves 2 times. Oh, my pen's running out, you guys. Anytime you have a decimal place, you just move 2 times. So we have 0.7, now we have 0.65. 5 over 8, I need to get the decimal form of that. I'm gonna write it down here. It's 0.625. And then 2/3 is 0.6 repeating. So remember that this has a lot of 6's and it keeps going forever and ever. And I could write them all out, or I could just make it nice and easy and put the line above the 6 and be done with it. All right, so now we have to figure out which one of these numbers is the smallest. So I go and look at the first decimal place. Obviously the 7 compared to all of these 6's is definitely largest, so I'm going to put that at the end of my answer choice. Oh, like that. And everything else is going to be in the front. Now I need to look for which one is actually the smallest. 0.65, 625, or 6 repeating. So a lot of people would see this 6.2 and say, oh, that's definitely the one. Or actually they might see this 6 and they say, oh, that's definitely the one because it's just a 6. This one is 65 and this one's 625. But the error that I just made is the way that I read it. I read this as 65 and it is wrong. This does not have a 65 value. It is 0.65, which means that this is still just a really, really, really tiny decimal. And this is a decimal as well. So let's move on. Since we are tied for the first decimal place, let's move on to the second decimal place. I added this 6 over here just so I could see what's happening. So we have a 5, a 2, and a 6, and now we are it's way easier to see which one is the actual smallest, which was this one. So I'm going to write the original value that it gave me, 5/8, as the first number because this was the smallest number. We figured it out. This would be the second smallest number, or the next smallest number, because 6.5 is smaller than 6.6, and then a bunch of other 6's repeating. So I'm going to put 65%. And then the next one is 2/3. Okay. One more problem about ordering numbers. Sometimes you might get numbers like this one, where it is a mixed number and not just a fraction. Sometimes we get improper fractions like these, where we have to figure out the decimal form, and sometimes we actually get mixed numbers. Now here's the way we do this. We take 12 and give it a decimal. I'm gonna write it right here, really tiny next to it. And we have to figure out what the decimal value of 1/2 is. If you do 1 divided by 2, you will get 0.5, which all I need to do is put the 0.5 next to my whole number, and that is the actual value for 12.5. 12.09, we don't have to do anything to it. 12.25, I do. So let's take 12, put a decimal, and then I'm gonna figure out what 2/5 actually is. So 2 divided by 5 gives me 0.4. So I just put the 0.4 at the end of that whole number. So the next thing that I need to do is not the next thing, but I do need to order them. And this time we are ordering them fastest to slowest. So these are race times. That means people are running a race and we're trying to win the race. Joe, Ellen, Steve, and Patty were running the race. So in order for us to find the fastest time, it's kind of tricky this way, because whenever you think fastest, you want to think the biggest, but it is not that way. When you're running a race, you are trying to beat everybody and be first and have the smallest time that it took you to get across the finish line. So let's look for the smallest decimal place. I have 12.09. 12.5, 12.4, and 12.8. Let's look at the very first place value since all of these are 12. The 12.0 wins. So Ellen was first. Ellen was in first place. She was the fastest. The next one would be Steve. Steve had 12.4. Steve is next. Joe had 12.5. Joe is next. And then last is Patty. Patty had 12.8, and that is the largest number, so she was the slowest. Poor Patty.